Welcome, dear listener, to episode 6 of Unveil the Future podcast, where we aim to explore the cutting edge of science and technology, making scientific concepts much more accessible and engaging for all. I'm Van Nguyen, your host, and today it is my absolute pleasure to welcome the very special guest, Dr. Itziar Aretxaga, the astrophysicist whose work has significantly advanced the galaxy formation as we know it today. Known for her astounding work in supernovas, galaxy formation, and her dedication to nurturing the young generation of astronomers, Dr. Itziar Aretxaga is truly one of the most inspiring and passionate astrophysicists. Her groundbreaking research has illuminated the intricate process that shaped the universe that we inhabit in. Her passion for unraveling the mysteries of the universe is matched only by her commitment to inspiring young minds through the International School for Young Astronomer programs. Now, without further delay, let us delve into the intricacies that is cosmic evolution and hear her insights into the intricate dance of matter and energy that shape the universe that we know it today. Thank you, Dr. Aretxaga, for accepting our invitation. It is such an honor for Unveil the Future podcast and our team for Wien Future Prize to have you for the first time ever. And as we embark on this journey, I am curious. Dr. Aretxaga, you were the first generation of your family to ever receive a university education. So growing up in a working class family, what initially sparked your interest in the universe, particularly in astronomy and galaxies?
Yeah, I come from a working class family, but it was a family that was well read. So there were lots of books at home, and there was a small budget for purchasing new books. And I actually, from very early on, since I started just having my own interests, my parents pushed me to pursue those interests. So I had access to books about astronomy. I had access about books about science in general. I was a teenager by that time, and I already was focused on science in general. But I would say that it was influential in me and many people in my generation in creating scientific vocations, and in particular interest for the space. But my focus on the space was just was something that developed through time. It was not just an immediate interest since a very early age. I would say from a very early age, I was curious about science, and I understood that science was this way of explaining the world. I mean, in my case, my parents were my drive force. They didn't have the opportunity to pursue university studies themselves. The conditions were not right when they grew up but they were very, very interested in life in general. And so they gave me the opportunity to pursue whatever I had an interest. I think that was the most important part, just having the support, a very strong support system from very early on, and that made me see that there was a world out there to be explored, and it was up to me to just go out there and understand it.
Your research interests cover galaxy formation, supernovas, and outbursts, which study the start of the universe and every galaxy that it contains. So what drives you to explore the cosmos and astrophysics? What do you see when you look up at the sky?
So when I decided I wanted to do astrophysics, I already knew that I like a link to how the universe had formed and evolved. But I thought that my abilities were better placed on the observational astronomy than on the theoretical astronomy. So that's why I look for work that had to do with the universe of galaxies, of how galaxies evolve. And so from the very beginning, I look for studies that had to do with that topic. I mean, the very beginning when I finished my bachelor's degree and I started doing a thesis. I started looking for a topic in which I could do research. So for me, it is very rooted in my human interest on knowing where we come from. I mean, there is a very human innate question that wants to understand why life has formed on Earth, why we are alive, where we come from, where we are going to. And now there are many different ways of trying to understand and give clues to that to that very big human question, right? And one of them is science, is try to understand what were the conditions in the universe that allowed intelligent life to be formed on Earth.
Throughout your research and career, could you share one of the most significant discoveries or breakthroughs you and your team have made, and how does it contribute to our understanding of the universe?
So I normally work not just with one galaxy in particular or with two or three. Sometimes we work with a rare one because we think that that will just give us some clues. But a lot of my work is devoted to understanding the population of galaxies as a whole, right? And where most of the star formation has happened in the history of the universe. In order to do that, there are many different methods and there are many different groups that are trying to make that measurement. But in the group in which I am working, what we are doing is trying to look for galaxies which are very, very, very obscure by dust in the universe. So stars normally form in big clouds of gas, which is mixed with dust, and dust are small deposits of heavy elements that obscure the light that from the stars that are newly formed and remit it in the far infrared and in the submillimeter wavelength. So by looking into wavelengths which are much longer than those which we can perceive with our own eyes, we can actually see the re-emission of this dust of the light of newly formed stars. So my contributions in the last, I will say, decade have gone into measuring what is the star formation rate in the universe. And in order to do that, you need to know not only how many stars are being born in a certain galaxy, but at what distance that galaxy is in order to locate it in a precise moment in the evolution of the universe. So the rate of star birth is not constant along the history of the universe. It is a law now that we are establishing. There are still some parts of that history that are missing and we are trying to complete. But we know the star formation started to pick up through time. It presented a maximum and then it declined to the present day. So my contributions have gone into this picture that has evolved, not just through my own work, but through the work both of my collaborators, students, and also through the work of other colleagues in the community that are working on the same topic.
Your work on active galactic nuclei has shined a light on understanding the evolution of galaxies and universe at large. Given the pivotal role of such studies in advancing our cosmic understanding, I am very curious about the future prospect of this field.
So when I started my PhD, I started working on active galactic nuclei. These are the centers of galaxies that nowadays is understood that have supermassive black holes. They have a huge accretion of gas around these black holes that actually is the main engine of light that comes out of these systems. But at the same time, because there is a lot of gas and there is dust, there is star formation. So at the time when I started working on these systems, the role of star formation was not very highlighted, and actually it was thought that it was completely unimportant. And now we have come to understand that both processes happen at the same time, and that stars around this feeding of the supermassive black holes is a key ingredient. And actually there is an interplay between both systems in stars, just providing part of the radiation, feeding also part of the enrichment of the gas around the AGN, and AGN being able to regulate the star formation, both in the nearby environments of galaxies as well as in larger areas of the galaxy. So active galactic nuclei, now we understand, are just an active phase of an ingredient that probably is at the center of every single giant galaxy. So it could be a period that is experiencing this type of activity. But more and more that we look into galaxies that we believe are purely star-forming galaxies, we see aspects that need to be understood with the presence of supermassive black holes. And now, whether those black holes are accreting gas in order for them to become active, and then we can just put them a label and say, okay, this galaxy is an active galactic nucleus, is an active galaxy, is another matter. But the precursor of creating that those conditions probably are already there. So, for instance, now that I'm looking into these huge populations of galaxies, looking at how the stars are being born, not just in the center where this putative supermassive black hole probably is, but in the whole structure of the galaxy, very often we find signatures of activity around the nucleus as well. So both things seem to come hand in hand. And indeed, this has been known now for some time. The history of accretion around supermassive black holes in the universe also has a curve that started just very low at the beginning of time. It went on increasing and it went on decreasing toward the present day. And the times when the maximum accretion happened are coincident when the times of maximum star formation happen. So both processes probably are very interlinked in the history and evolution of galaxies.
Beyond your passion for scientific discovery, you are also deeply committed to provide critical knowledge to students in regions with limited access to astronomy mentorship. You are a fellow of the World Academy of Science, and your work has been instrumental in cultivating scientific talent in developing nations. So I'm curious, given your experience with TWAS, how do you assess the potential of scientists from countries such as Vietnam in this field?
This is a huge organization of scientists around the world that have made contributions to the development of their own countries and other countries which are perceived to be developing. And there are also scientists that work in well-developed countries that have this interest of seeing the world being a more just type of system in which all the talent can be recruited in order to pursue scientific interest, if that's their interest. Collaboration among different developing countries, and also in north-south type of relationships in which scientists can go and pursue maybe graduate studies in well-developed countries and then return to their own countries, or go to other countries and make a contribution to the development of the scientific communities in those other countries. So I will say that that's one of the main goals of the Academy of Sciences.
And regarding Vietnamese contact and potential, how do you believe awards like the Vietnam Future Prize can help inspire greater interest in research and innovation?
I mean, having prizes is actually very important. I mean, it basically showcases for the general public big advances, and it basically puts faces to advances. But I will say we work just driven by our internal questions of wanting to solve a problem, and then sometimes people are recognized with prizes for their big achievements, and that's great. It's a celebration. It's something that basically everybody else can focus on that new advance and say, look, it's really well deserved. It's the pursuit of a new knowledge, is the pursuit of the understanding of something that is not yet understood, that is at the frontier of our knowledge.
Being the director of International Schools for Young Astronomers, your vision is to bring the opportunity to students in developing countries. How do you see the role of studies in technology and in astrophysics in impacting the next generation of scientists and engineers?
I think it goes hand in hand. I mean, in my institute, we have two different graduate programs. One of them is on astrophysics and astrophysical instrumentation, and the other one is on space technology and space science. They are different programs, but they are related. But I mean, our human tendency is to make boxes, right? And so we just call something physics, and there is something that we call chemistry, and there is something that we call biology, and there is something that we call astronomy. And we believe that we work within these closed boxes, while there are a lot of breaches between all those boxes. And we have just the interplay of the experience from those professionals working in one of the supposed boxes with the others. So space exploration. I mean, I think people who are interested in astrophysics are naturally interested in space exploration, in the planets, or in the view of Earth as a planet from space, which is one of the missions of space exploration. So renewed interest in one of the topics means renewed interest in all of them. And this we have seen time and time again. When there are big missions, like now Artemis, just going back to the moon, it infuses a whole generation of new, of youngsters that suddenly think they can contribute to that effort. Our programs, the International Schools for Young Astronomers, as other programs around the world, are trying to tap into that talent that is distributed around the world. But we certainly love to see that there are people who are tremendously successful in their careers that are working in their own country, and that they are returning knowledge and passion for science in their own countries. So that's tremendously important.
Now, let's turn our attention to one of the most thrilling developments of space exploration this year. NASA's announcement of the Artemis Project has ignited global fascination with the cosmos once again. These ambitious missions aim to return humans to the moon, making history by landing the first ever woman and the first person of color on the planet. So, understanding the importance of being the first, from the first in your family to ever change future through further education to one of the first to ever elevate a Mexican standing in astronomy landscape. What is your perspective on NASA initiative?
I think it is great that there is a little bit more of equality in the selection of candidates for these very big missions. I think it has an important message. That we are creating a more equal society, and that hopefully, yes, the value of the person for the mission is the most important criterion for selection, but then that we are looking into whether there are biases in our selection of the final person that goes into the mission. So it is a very important message for the world, the fact that they have selected a Black woman. Is just targeting two minorities, in a sense, within the technological and scientific community. Women are half of the population, but we are not half of the scientific force or the technological force. And likewise, I mean, there is a variety of ethnical backgrounds, which we do not see normally in equal representations as they are in our cities, in the scientific and technological teams. So I think that's a message that goes very in hand with our times of showing a more equal world. It is important. And then it is very important, the Artemis mission is returning to the moon with a human being. And this is tremendously impactful and thrilling. And I think it will be, again, one of the drivers to generate enthusiasm in the new generations of the scientists and technologists to be.
The Artemis Project marks the first return of humans to the moon since 1969. So do you believe that this is a significant step forward to the human space exploration?
Absolutely. I mean, the first visit to the moon, it was made in a historical context that basically was driven by the competition of two big blocks in the world, right? And it was abandoned once it was achieved. It was done with very feeble technology, important technological developments at the time, but compared to the technology we have nowadays, it's almost scary to think that human beings were sent to the moon under those circumstances and technology, right? So in a sense, it has been a pity that for so many decades, human beings haven't pursued more space exploration and the understanding of the astronomical objects near Earth. I mean, start with the moon, which is the nearest thing that we have, right? So Artemis has as the big goal in the long term to have a manned mission, so to send human beings to Mars. And in order to have that big goal, you need to take smaller steps first. And so the first step is to return to the moon, return to the moon, not only with the so successful missions that have happened up to now with robots, but to send people out there and to conduct both the studies of how the human body reacts to space for long times, and also conduct the experiments that are scientific experiments that the mission will have. So the goal is not only to just visit other celestial bodies, but it is also to conduct experiments that will make us understand better what the moon, what the planets are made of, and what are the conditions for experiments in those environments.
Such is a hopeful message for mankind. And that concludes the episode for today. Thank you, Dr. Aretxaga, for sharing this. You have ignited our imagination and expanded our cosmic perspective. And to our dear listener, thank you very much for joining us on this celestial journey. Your curiosity is the driving force behind exploration, and we are grateful for your company. Don't forget that the Win Future Prize is now calling for nomination for the 2025 Win Future Prize. Check out the link below for more information. If the perspective and knowledge in this episode ever excites you, don't hesitate to hit the like and subscribe button and keep supporting the Unveil the Future podcast. Until next time.